So we talked about, different segments and how we can go about, doing segmentation. And again, I want to reiterate, segmentation is something that software is not going to be able to help you a lot with it. Of course, HCS has automatic segmentation features in it that's going to help you do that. But regardless, you need to sort of, verify that and also make sure that that's done right. So that's important for you to make sure that you understand segmentation. And I have one example here with few steps. If you want to do segmentation, if you follow these steps, it's going to make sure that you are not going to miss anything. So up until now, you have all the knowledge to go about segmentation of this freeway that I'm showing to you here on this slide. But let me go through these steps and one by one to basically try to create segments and basically designate their lengths into that. So obviously, the first thing is that you need to define where your facility starts and where your facility ends, because that's going to act as like first and last segment's boundary. And one thing to make sure that you consider is that facility should contain queuing. So if you are doing basically you want to do an analysis for a freeway that has congestion, let's say you want to see how you can mitigate congestion, you need to start from somewhere and end somewhere that basically contain the queue within analysis. And obviously, we want to start the segment with the basic segment and end the segment with the basic segment. So we should not like end our freeway facility at the middle of a weak segment. So again, two things to consider. One, this boundary basically start and end doesn't hit congestion. Start and end basically creates a basic segment. So for example, on this example that I'm showing you, this first segment is basic. This last segment is basic as well. So then for step two, we look into lane adds and lane drops, plus anything that's going to change free flow speed. So if you remember, I said one of the limitations of HCM is that it's not sensitive to speed limit. So we don't have a speed limit as an input parameter for any computation. But obviously, speed limit is going to change free flow speed. So if we go and measure speed basically on this freeway, we expect to see differences basically, where speed limit is 65 versus where speed limit is 55. So right, that point basically is going to act as one segment boundary. And of course, when I look into here, we have one lane drop. So this is not the on-ramp segment. So on-ramp segment and acceleration lane is where I'm showing with my mouse. But this thing is called lane drop. So lane and lane drop are capacity changes, and that acts as a segment boundary. So there are like two segment boundaries here that we draw, and we move forward. So step three, we want to identify gore points, and potentially they're going to act as segment boundary, but they may not, because if that's weave segments, we need to account for that 500 feet upstream and downstream. So as you can see here, whatever I have it in blue, it means that it's segment boundary. Up until now, it's fixed. But like green ones are like, all those gore points. And what we want to do is that for all those gore points, if they are associated with merge and diverge segment, that's a segment boundary. As you can see, they're all turned blue. But if it's associated with a weave segment, here we have this auxiliary lane. So this guy is a weave segment. So we need to go up 500 feet as well as, go down 500 upstream and downstream. And that's going to be basically the segment boundaries, not the gore points. In the next step, then we want to go about reserving that 1,500 feet for our merge and diverge segment. So we start from here. So we see here that, this stretch is 2,500 feet, and easily we can designate 1,500 feet for our merge segments. So we have no issues here. We move forward. Then we come here, we see that, so this stretch is already 1,200. We cannot designate 1,500 feet as our segment length. So that's an ideal segment length for merge and diverge. But here we have no other option. So we cannot increase it because, we have another gore point, another turbulent area, we have it there. So we are going to stick with 1,200 feet. So technically ramp influence area here is 1,200 feet, a stretch, as well as segment length is 1,200 feet as well. Then we come to this section and, we have an on-ramp followed by an off-ramp, and there are no auxiliary lanes between them. Of course, now we go about and see, how we can do the segmentation here. Are we going to end up with just one merge and one diverge? Or do we have basic segment or overlapping segment in between? So I see the distance between the two gore points are 3,500. So easily I can designate 1,500 feet for my on-ramp segment and 1,500 feet for my off-ramp or diverge segment. And that's going to leave basically, 500 feet at the middle to designate as a basic segment. HCM has one requirement, and that is to not have segments less than 300 feet. So that's why I said, if the distance between 2 points is about 3,000, we divide it into just one merge and diverge. But 500 is more than 300 feet, so we can easily basically create this 500 feet basic segment. So then we go to basically next step, which, we want to basically designate all the segments, what type they are, what length they are, and we are already basically done with it. Oh, actually, I think by mistake, I bypassed here. So in slide 268, we have this other, merge followed by diverge segment where the distance between the two is 2,000. So if we want to designate 1,500 feet for merge and 1,500 feet for diverge, we are going to end up having about 1,000 feet overlapping segment. So this segment on the right side of the screen is going to be our overlapping segment. So then we go to this slide, and here it shows that basically how we did this. This is the summary of the segmentation. We have all the segment types. B basically, refers to basic, M is merge, D is diverge, W is weave, and O is overlapping segment with their associated segment lengths.